Hello everyone, welcome back to the Atharva Gate Academy, myself Chinmay Dhaduk. In this video, we will continue to solve previous year GATE questions of strength of materials of chapter 2, that is stress and strain. This question is from year 2012. This question is little bit difficult, but after understanding the concept, it will be easy for you. A solid steel cube constrained on all 6 faces is heated so that the temperature rises uniformly by delta T. If the thermal coefficient of material is alpha, Young modulus is E, and Poisson's ratio is mu, the thermal stress developed in the cube due to heating is, and here we have these 4 options. Now in the question it is given that we have this type of cube and here dimension will be same in all the direction. Let's say here we take this direction as x direction, this direction as y direction, and this direction as z direction. Now here it is given that this steel cube constrained on all the 6 faces. Means we can say that change in dimension in all the 3 direction is restricted. Understand that if this is the cube in 2 dimension, then we restrict all the surface like this. And this front and back surface is also restricted. Means here change in dimension is restricted. And we are increasing the temperature delta T. Then we have to find out thermal stress produced in this cube. Now we know that if we increase temperature of this body, then dimensions of this body is going to be increased. But here we are restricting the change in dimension, so thermal stress is going to be developed in this body, right? And we can understand that stress in all the 3 directions will be same. Means if we take sigma T as thermal stress in x direction, then it will be same in y direction and it will be same in z direction. And here we have to find out this value of thermal stress. Fine. So I hope that you understand the question. Now I will tell you that how to solve this question. First of all, we will allow change in dimension of this body by changing temperature delta T. Means first of all we are assuming that there is no restriction to change in dimension of this body. Now we can understand that by changing temperature delta T, dimension of this cube is going to be increased. Means volume will increase like this, right? And here this another color is original dimension. So I hope that you can understand how the volume is increased, right? We have discussed in the theory part that strain in x direction, strain in y direction and strain in z direction by this change in temperature delta T for this cube will be alpha delta T, right? It will be same in all the 3 direction x, y and z. Now we know that actually this cube is restricted on all the 6 surfaces. So actually this change in dimension is not allowed. So now we will apply compressive load in this cube from all the 3 directions in such a way that this cube regain its original dimension. Means here we are applying sigma stress in all the 3 directions and it is compressive in nature. So due to this stress, volume of this cube is going to be decreased, right? And we are applying this stress in such a way that this cube regains its original volume, right? And now we know that for 3D loading condition, if you want to find out strain in any direction, let's say here if you want to find out epsilon x, then it will be sigma x divided by E minus mu into sigma y divided by E minus mu into sigma z divided by E, right? That we have discussed in the theory part. Now here we can see that value of stress in all the 3 direction is same and it is minus sigma because it is compressive. So actually this value of epsilon x will be minus sigma into 1 minus 2 mu divided by E, right? Here you can see that this strain is negative because here in x direction dimension is decreasing, right? Now here we can compare this value of strain and this value of strain because this both is going to be equal, right? So from here we can say that alpha delta t is equal to minus sigma into bracket 1 minus 2 mu divided by E. Alpha delta t is equal to minus sigma 1 minus 2 mu divided by E. And here this sigma is nothing but the thermal stress sigma T. So it is sigma T. And from here if you will simplify this equation, then you will get sigma T is equal to minus alpha delta T into E divided by 1 minus 2 mu. Means option A is correct. Now there is also another method to find out thermal stress. It is little bit similar, but it is different from here. From here we can find out epsilon V by change in temperature. It will be epsilon x plus epsilon y plus epsilon z, right? So ultimately it will be 3 alpha delta T. That is the value of volumetric strain by change in temperature delta T in this cube. And now if we apply this compressive stress sigma on this cube, then there will be volumetric strain by this stress sigma, right? And we know the equation to find out volumetric strain for 3D loading condition. It is sigma x plus sigma y plus sigma z divided by E into 1 minus 2 mu, correct? And here we know that sigma x, sigma y and sigma z is same, that is minus sigma. So we can say that it is equal to minus 3 sigma divided by E into bracket 1 minus 2 mu. And this volumetric strain and this volumetric strain should be equal, right? Because after applying this compressive stress, this cube is going to be regain its original volume. So we can compare these two values. It will be 3 alpha delta T. So from here we can also find this sigma, and from here you will also get this value. Fine. So I hope that you understand. Here I will repeat this concept. First of all, we removed all the constraints, or we can say we remove all the restriction from this cube, and we allow this cube to deform in all the three directions x, y and z by this change in temperature delta T. After increasing the temperature delta T, there will be increase in volume of this cube. Now we are applying compressive stress sigma on all the faces of this cube, and we will apply this stress in such a way that this cube will regain its original dimension and its original volume. Then we find the value of strain in any direction by this change in temperature and by this compressive stress sigma, and we equate this both the value of strain, and then we can find out stress. Fine. And here we can compare strain in x direction, or we can also compare volumetric strain in this body. So finally you will get value of stress in this body. And here this question is for 2 marks. Next question is from year 2013. A rod of length L having uniform cross-sectional area A is subjected to a tensile force P as shown in the figure below. If the Young modulus of the material varies linearly from E1 to E2 along the length of this rod, the normal stress developed at the section SS that we have to find. In the figure you can see that we have this rod of length L, and we have to find value of normal stress at section SS, which is the mid section of this rod. And here Young modulus of this rod is varying from E1 to E2 along the length of this rod, and it is varying linearly. Here we apply tensile force P along the length of this rod. We have to find out normal stress sigma. In the theory part we have discussed that stress is internal resisting force per unit area, and it is independent of material property like elastic constant. And we know that elastic constants are E, G, mu and K. But it depends on material geometry, means it depends on area. So here we can say that value of stress does not depend on value of Young's modulus. It only depends on value of force and the cross-sectional area of this rod. And we know that normal stress is equal to P divided by A. So here our answer will be option A, P divided by A. So it is very simple question, but you should be having some idea that the stress does not depend on the value of E, G, mu and K. Fine. Next question from year 2014, paper set 1. A circular rod of length L and area of cross section A has modulus of elasticity E and coefficient of thermal expansion alpha. One end of the rod is fixed and other end is free. If the temperature of the rod is increased by delta T, then we have to choose correct option from these 4 options. Here it is given that we have one rod which is fixed at one end like this and it is free on this end. We are increasing the temperature of this rod by delta T. In this case, we have to choose one option from these 4 options. First option is stress developed in the rod is E alpha delta T and strain developed in the rod is alpha delta T. Option B is both stress and strain developed in the rod are 0. Third option is stress developed in the rod is 0 and strain developed in the rod is alpha delta T. And option D is stress developed in the rod is E alpha delta T and strain developed in the rod is 0. Means actually here we have to find out thermal stress and thermal strain. Now here we know that this rod is not restricted on both the side. Means if we increase delta T temperature of this rod, then change in length of this rod is allowed. Means length of this rod can increase like this. And we know that if there is no restriction to change in dimension, then it will be the case of free expansion, right? And we have discussed earlier that in the case of free expansion, value of thermal stress is 0. Means in this case, value of thermal stress is 0. Because here there is no restriction to change in dimension of this rod. Now here we have to find out epsilon T. We know that delta L is equal to L alpha delta T, right? So from here we can say that delta L by L is equal to alpha delta T and it is change in dimension divided by original dimension, that is thermal strain epsilon T, right? So here we can say that epsilon T means thermal strain developed in this rod is alpha delta T. And we have already remembered this equation that thermal strain is equal to alpha delta T. So here our answer will be option C. Stress developed in the rod is 0 and strain developed in the rod is alpha delta. This question is for 1 mark. Now the next question is from year 2014, set 1. A metallic rod of 500 mm length and 50 mm diameter, when subjected to a tensile force of 100 kN at the ends, experience an increase in length by 0.5 mm and a reduction in its diameter by 0.015 mm. Means here initial length is given, that is 500 mm, initial diameter is given, that is 50 mm. After applying this load P, it is having value 100 kN, means 100 into 10 raised to 3 Newton. Its increase in length is 0.5 mm, means delta L is 0.5 mm, and its reduction in diameter is 0.015 mm, means we can say that delta D is equal to minus 0.015 mm. In this case, diameter is decreasing, so delta D will be negative. Fine. And in this case, we have to find out Poisson's ratio of this material of rod. Means here we have to find out mu. Here metallic rod is like this. This is length L and this is diameter D. We apply tensile load P on both the sides like this. We know that how to find Poisson's ratio for this case. We know that Poisson's ratio mu is equal to minus lateral strain divided by linear strain. Here direction along the force applied on this body will be linear direction and direction which is perpendicular to this direction will be lateral direction. Means here this direction is linear direction and this direction is lateral direction, right? Now in this case, what will be the value of lateral strain? Lateral strain will be change in lateral dimension divided by original lateral dimension. Means it will be minus delta D divided by D, right? And what will be the linear strain? It will be change in dimension in linear direction divided by original linear dimension. So it will be delta L divided by L, right? Now in this expression we have all the values. Now we will put all these values in this expression. So it will be minus delta D, that is minus 0.015 divided by initial diameter is 50 mm divided by delta L is 0.5 divided by initial length is 500 mm. Here you have to take all the units in same unit, means you have to take all the units in mm, or you can also take all the units in centimeter or meter, right? After calculating this value, you will get Poisson's ratio mu is equal to 0.3, and it will be positive because here minus into minus sign will be positive. Fine. So in this question answer is mu is equal to 0.3, and in this question there is no any option. We have to write 0.3 here. Fine. And this question is for 1 mark. Next question is from year 2014, set 1. A 200 mm long stress-free rod at room temperature is held between two immovable rigid walls. Means rod is fixed between two fixed surface, or we can say two fixed wall, right? And length is given as 200 mm. The temperature of the rod is uniformly raised by 250 degrees Celsius. Means here delta T is equal to 250 degrees Celsius. If the Young modulus and coefficient of thermal expansions are 200 gigapascal and 1 into 10 raised to minus 5 per degree centigrade respectively, then the magnitude of longitudinal stress in megapascal developed in the rod is dash. Means here value of E is given as 200 gigapascal, means it will be 200 into 10 raised to 3 megapascal, and value of alpha is given, that is 10 raised to minus 5 degree centigrade inverse. Fine. And in this case we have to find out magnitude of longitudinal stress, means we have to find out stress, and that will be actually thermal stress, right? Now we have derived the equation to find out thermal stress in this case. We know that sigma T means thermal stress is equal to E alpha delta T, correct? And here we have values of E, alpha and delta T. E is given as 200 into 10 raised to 3 megapascal. This alpha is 10 raised to minus 5, and value of delta T is 250. Here this E is in megapascal, this alpha is in centigrade inverse, and this 250 is in degree centigrade, right? So finally you will get value in megapascal, and if you will calculate this, then you will get 500 megapascal, and that is going to be the value of thermal stress in this rod. Now understand one thing, that here we are increasing the temperature, so the length of this rod is going to be increased, and by this wall there will be compressive reaction on both the side of this rod, and due to this compressive reaction there will be compressive stress in this rod, means actually this stress will be compressive stress. So we have to take this value as negative 500. But in the question it is only asked the magnitude of the longitudinal stress. And remember one thing, that whenever it is mentioned that we have to answer the magnitude, then we have to neglect the negative sign. Means if our answer is minus 500, then we have to only write 500. We don't have to write this negative sign. Fine. And if magnitude word is not mentioned in the question, then we have to write minus 500 in this blank. Otherwise you will simply lose 2 marks. In this case, there is magnitude word is mentioned in the question, so we will write this value as positive. Means we only have to write 500 in this blank. Fine. Now the next question is from year 2014 paper set 2. A steel cube with all the faces free to deform has Young's modulus E, Poisson's ratio mu and coefficient of thermal expansion alpha. The pressure, and here it is hydrostatic stress, developed within the cube when it is subjected to uniform increase in temperature delta T is given by dash, and here we have these 4 options. Understand carefully that in the question it is given all the faces of this steel cube are free to deform. Means if we have cube like this, then there is no any restriction of the deformation of this cube. Means this cube is not restricted on any faces. If we increase delta T temperature of this cube, then dimension of this cube is going to be increased in all the 3 directions. Fine. So here we can say that this case is the case of free expansion, right? Because there is no any restriction to change in dimension of this cube, and we know that in the case of free expansion value of stress is 0. Means here value of pressure developed within the cube, or we can say hydrostatic stress developed within the cube, will be 0. So in this case answer will be option A, 0. Fine. So it is very easy and it is for 1 mark. Now the next question is from year 2014 set 3. The stress strain curve for mild steel is shown in the figure given below. Choose the correct option referring the both figure and table. Here these are the points on the stress strain curve and this is the description of the point. We have to choose the correct option from these options. In the theory part we have discussed the stress strain curve for mild steel. We have discussed this curve, right? Here we know that first of all there is proportional limit, then there is elastic limit. Here this point is upper yield point, this point is lower yield point, this point will be ultimate point and this point will be fracture point, right? In this stress strain curve this portion is shown here. So now we can write all these points from this stress strain curve. This upper yield point will be this point, that is point R. This ultimate tensile strength will be here, means this T point. This proportionality limit is at the point P. This elastic limit is point Q. This lower yield point is point S and failure occurs at point U. Now see, in the GATE questions, if this type of question is asked, then first of all you have to see the options. In the options you can see that this R point is having different numerical value in all the 4 options. So if you know that this R point is upper yield point, then you can directly choose the option that answer is option C. Means in less time you will be able to answer this question. Here you don't have to compare all other points. Fine. And this question is for 1 mark. Next question is from year 2014 paper set 4. If the Poisson's ratio of an elastic material is 0.4, the ratio of modulus of rigidity to Young's modulus is dash. Here mu is given as 0.4 and we have to find out ratio of G to E, modulus of rigidity to Young's modulus. Fine. Now we know the relationship between the elastic constant E, G, K and mu. And here by comparing these two terms we can find out ratio of G to E. So from here we can say that G divided by E will be equal to 1 upon 2 into bracket 1 plus mu. Right? And here we have value of mu, that is 0.4. So it will be 1 upon 2 into bracket 1 plus mu. So it will be 1 plus 0.4. So if you will calculate this, then you will get value 0.357. And here in this question you have to write 0.357. Fine. And this question is for 1 mark. Next question is also from same paper. The number of independent elastic constants required to define the stress-strain relationship for an isotropic elastic solid is dash. I have given you this table in the notes, and we have already discussed this table in the topic of elastic constant. From this table we can answer this question. For homogeneous and isotropic material, number of independent elastic constant are 2. So here our answer will be 2. And we know that total number of elastic constant are 4. That are E, G, K and mu. Out of these 4 elastic constant, 2 elastic constant are independent. Fine. Now the next question from year 2015 paper set 1 is, which of the following types of stress-strain relationship best describes the behavior of brittle materials, such as ceramic and thermosetting plastics? These two materials are brittle materials, and we have to select the stress-strain diagram for brittle materials. Now understand that the toughness of brittle materials is less and toughness of ductile material is high. Means we can also say that area under stress-strain curve will be larger for ductile material and it will be less for brittle material. From these 4 options we can say that area under stress-strain curve will be less in this option D. Right? Area under stress-strain curve means this area. And you can see that in option A, B and C, this area is larger. And in option D, this area is less. Means this stress-strain curve is for brittle material. And we can also understand these diagrams in another way. We know that brittle material fails before large amount of deformation in the material. And here in the diagrams you can see that in option A, C and B, this deformation is very large before this fracture point. But in the option D, this deformation is less before fracture point. Fine. So our answer will be option D. And we have also discussed this other stress-strain curve in the theory part. Right? So you can see the notes. This question is for 1 mark. Next question is from year 2015 paper set 2. A rod is subjected to a uniaxial load within linear elastic limit. When the change in the stress is 200 megapascal, the change in the strain is 0.001. If the Poisson's ratio of the rod is 0.3, the modulus of rigidity in gigapascal is dash. Here it is given that rod is subjected to uniaxial load. Means it is like this. Here it is axial load, so here the stress will be normal stress and change in stress is given. Means delta sigma is given as 200 megapascal and change in strain is given delta epsilon is equal to 0.001. Right? Poisson's ratio is also given as 0.3. So mu is equal to 0.3. And here we have to find out modulus of rigidity in gigapascal. Means value of G. Now see, we know the equation that sigma is equal to Young modulus into epsilon. Right? And we know that in stress-strain diagram up to proportional limit it is linear line like this. Here there is engineering stress and here there is engineering strain. And here the slope of this line is Young modulus. Now this is the equation from zero loading condition. Means if we apply this stress value from zero loading condition, then this equation is satisfied. But if change in stress and change in strain is given, then we have to use equation of E is equal to delta sigma divided by delta epsilon. Means it is nothing but the slope of this line. Right? So from here we can find out value of Young's modulus. It will be 200 megapascal divided by this strain 0.001. So finally it will be 200 into 10 raised to 3 megapascal. Here unit of stress is megapascal, so unit of Young's modulus will be megapascal. Now we also know the relationship between G, mu and E. We know that E is equal to 2G into bracket 1 plus mu, right? And here we have value of Young's modulus and we have value of mu. So from here we can find out value of G, that is modulus of rigidity. It will be E divided by 2 into bracket 1 plus mu. So it will be 200 into 10 raised to 3 divided by 2 into bracket 1 plus 0.3, right? And here this value will be in megapascal because here value of E is in megapascal. If you will calculate this value, then you will get 77 into 10 raised to 3 megapascal. And in the question we need answer in gigapascal. So to convert this megapascal value into gigapascal, we have to multiply this value with 10 raised to minus 3, right? So it will be 77 gigapascal, right? So here we have to write answer 77. And this question is for 1 mark. Next question is from year 2016, paper set 1. A horizontal bar with a constant cross section is subjected to loading as shown in the figure. The Young's moduli of the section AB and BC are 3E and E respectively, that is given in this figure. For the deflection at C to be 0, the ratio of P divided by F is blank. Means here we have to find the ratio of P divided by F, and we want the value of deflection at surface C 0. Means actually deformation between surface A and surface C should be 0. We can say that delta between AC should be 0. Now in the figure it is given that area of this rod is constant, let's say that is A, and here length is given of AB segment and BC segment, that is L. Young modulus for this AB section is 3E and Young modulus for BC section is E. And here we apply compression load P in this direction and here we apply one tensile force in this direction. Now we know that deformation between AC is equal to deformation between AB plus deformation between BC. So we can say that delta AC is equal to delta AB plus delta BC, right? We have equation to find out deformation under axial load, that is PL divided by AE. So here we can write that it is equal to PL by AE for section AB plus PL by AE for section BC. In this expression, length, area and Young modulus is given. We have to find load in each segment. To find value of load in AB segment, we will take one section between surface A and B. And we will take summation of all the forces acting either side of this section on this rod. Here we will take summation of the right side of the forces. And here you can see that this F load is acting away from the section and this P load is acting towards this section. So we can say that load in AB is equal to plus F minus P. And to find out load in part BC, we will take one section in part BC like this and we will take summation of forces either side of this section acting on this rod. Here again we will take summation of forces right side of this section. And on the right side there is only one force, F is acting. So we can say that P means load in part BC is equal to plus F. Because it is acting away from the section, here we take positive sign. Fine. Now we know that delta AC should be 0. So this value should be 0. So from here we can say that 0 is equal to P for AB is F minus P into length of AB section is L divided by area is taken as capital A into Young modulus for AB section is 3E plus value of P for BC part is plus F. And length of this BC part is capital L. Divided by area is taken as A and value of Young's modulus is E. Now from here, if you will take length, area and Young's modulus constant, so it will be F minus P divided by 3 plus F. And here if we will take this L divided by AE constant at the left side, then it will be 0 divided by this L divided by AE. So finally it will be 0. So we can say that 0 is equal to F minus P divided by 3 plus F. And now from this expression you can easily find ratio of P divided by F. If you will find ratio from this expression P divided by F, then it will be 4. Fine. So here our answer will be 4. There are no options given in this question. Here we have to write 4 in the blank. Fine. And this question is asked for 2 marks. Next question is from year 2016, paper set 2. The value of true strain produced in the compressing a cylinder to half its original length is dash. And here we have these 4 options. Means we have to find out true strain epsilon T for the cylinder which is compressed to half length of its original length. Means if its initial length Li is L, then its final length is L by 2. Right? We know the equation of true strain, that is integration dl by L from length L1 to L2. And we have derived that it is equal to ln 1 plus epsilon, and this epsilon is engineering strain, right? So it is equal to ln into bracket 1 plus delta L divided by L. Here this delta L is change in length and this L is initial length. We have derived this equation in theory part, right? So you directly have to remember this equation. True strain is equal to ln into bracket 1 plus delta L by L. So from here we can find out delta L, that is equal to final length divided by initial length. So it will be L by 2 minus L. So delta L is equal to minus L by 2 and initial length is L. Fine. So if we will put this value here, then it will be ln into bracket 1 plus delta L is minus L by 2 divided by initial length L is L. So it is equal to ln into bracket 1 minus 1 by 2. So it is ln 1 by 2 means ln 0.5. And here it is natural log. It is not log base 10. If you will calculate this value in the calculator and this value in the calculator, then it will be different. Here base of this log is E. Fine. So from here if you will calculate this value, then it will be minus 0.69. So here our answer is option B, minus 0.69. And also understand one thing, that in the question it is given that value of true strain. If it is given that magnitude of true strain, then we have to write 0.69 as positive. Fine. So here this is very simple question and it is for 1 mark. I hope that you understand these questions and solutions. If you have any doubt or if you have any suggestion, then you can tell me in the comment box. Today we will stop here and we will continue in the next video. If you like this video, then make sure that you hit the like button and also share these videos with your friends so that they can also take benefit from this channel. Now we will meet in the next video. Till then, stay motivated and happy practicing.